annual conference. This is actually the first live event since 2020. So attendance is going to be a little bit hard to foresee. But welcome to attend our afternoon session.
Up next is the fourth speaker for today, Dr. Eliza. And she authored over 100 top-tier technical papers and conference papers and more than 30 patents. So I will hand over to Professor Du.
Good afternoon, everyone. Oh yeah, it's late. Let's say it again, right? Good afternoon. How are you? Good afternoon. Okay. Yeah. Probably with mask, right? That's why it's still it's afternoon. So I will promise not much mask here. There's 0 mask probably, and it will be fun. And let's enjoy. And there's a lot of things unknown, so I will be happy to discuss with you and to see what we can do in this Metaverse world. So what is Metaverse, right? There's a lot of myths and a lot of discussions about that. And Facebook was changed to Meta last year and has a lot of discussion about what is Metaverse. Let's see, what Hollywood think, right? A lot of sci-fi movies oftentimes predict about future, and let's see how they think about what Metaverse is. Can you play video or somehow this sound? So this is from Real Player One, and that is about VR, right? That is in the future. There's a Oasis, and the people can get there and then to be use the 3D avatar truthfully represent your behavior, your actions, and people use wearables and to feel and to touch the virtual world and to interact with other people. And basically, it's the whole thing are virtually represented. We see that as a VR, virtual reality. Let's move to. Okay, let's move to the next one. This one is a Free Guy. I don't know if you guys watched that movie. It's from. Can you play the movie? Can you help click them? So this one shows what is an AR is, right? You wear the glasses, you see a whole new different world around you. You see instructions, you see weapons, you see cool stuff. And then you take off the glass. It's just a boring world. That's kind of like the future of the AR glasses. We're not there yet, right? Can you play this one? This one is Cloud Atlas. It's about in the future, if you don't have wear glasses, right, and you go to your room and how the decoration, the things will work. You see that guy has some similar click as I did.
This is your bed. These are your clothes. You look lovely.
So when you go to the room, it looks plain, but with the display, with that technology, you kind of go to a different world. You can change different seasons. You can change different decorations. You can watch movies, you can do a lot of different things with that kind of display, kind of augmented reality world. Let's look at this one, right? So holographic AR, right? How do we really, in our imagination, holographic AR should be, right? Look at this Iron Man clip. Wouldn't that be cool, right? When you want to design your engineering things and solve the biggest problem in the world, and you just use your hand and you can see and you can interact, you can change and then to make things happen. Can you kindly click play? Look at this interaction between the person and the display and the things. There's no keyboard, no mouse. It's use hand gesture, movements, use voice control. So we call those kind of interface natural user interface. That is more beyond the before, right? We heard about GUI, graphic user interface. So what is a metaverse, right? Metaverse is actually defined as a Web 3.0. I think if we talk about Web 3.0, and people feel it's more realistic, and it's coming, right? We have experienced Web 1.0, which is just internet. Web 2.0, that is a smartphone, mobile phone internet. And this is Web 3.0. And it has a lot of applications. The major differentiation between Web 3.0 and Web 2.0 or Web 1.0 is how you integrate with virtual world and real world together. And that's the key to define what is Web 3.0 or Metaverse. And that's will have a lot of applications. And so there's a major characteristics that we would define that is qualified as a metaverse. First is presence, 身临其境, right? It means you feel inside that kind of world, and you feel you can control those kind of world. It can be VR, can be AR, can be MR, right? And it's also because you wanted to go to a virtual world, so there is a presence of the virtual world. 虚拟世界, right? And then, how do you get from one virtual world to another virtual world, or from real world to the virtual world? We call it teleporting, right? And then you feel realistically, you feel you are transferred from one location to another locations. And then, because of this, you can, use different devices, different platforms, and you want it to be not only just into the virtual world, but whatever your controls in the virtual world will have real world impact, or vice versa. The real world things can impact in your virtual world things. And that's how, the cross-platform interpolation will be very important. And then, because this is people will have a lot more data. It's not a more personalized data, not just your browsing data, but also your behavior data and your expression data, your control data, and then a lot of your presence data. So the data security and the cybersecurity will be important in the metaverse. But doesn't mean only metaverse need cybersecurity. That part does not use to qualify if it's a metaverse or not. It's metaverse. This part will be important. It's much more important: security, privacy, and data integrity. And then, because this metaverse heavily we are in the virtual world, and women working in the virtual world, so there could be the virtual item, virtual things to sell, right? And probably you heard about NFT, right? They talk about how do you have an image, you create something, you can sell, and you can people make a lot of money. Well, I would say NFTs not necessarily represent metaverse. It could be an application of metaverse. There could be many different presentation of things, and there's probably different market for you to sell and to buy things. But anything involves business, right? You need to be careful. There could be win, could be lose. But that is extra things we can talk. So this is virtual goods, right? Virtual items, things you can buy. And again, in the metaverse, that is one thing is important, is become natural user interface. You no longer use keyboard or mouse to do interaction. It's more and more human-like action. I never talk to another person by use my finger to tap in your face or your body. You did not do that to another person either. That's how human to machine interface will become. And the impact, the economic impact and the prediction of the metaverse may vary, right? If you look back to 1990s or early 2000, they predict the impact of internet. Or if you look at it in 2005 or 2006, or just when iPhone came out, talk about impact of Web 2.0, you will find that number is much lower and actual impact. Web 1.0, from the existence of the web to now, they projected, so far, they calculated the revenue, or you say the impact, economic impact is $1.1 trillion, and mobile internet, or the Web 2.0, they estimate impact is $5.9 trillion, and then they estimated the impact of the metaverse, the Web 3.0, is much bigger. I'm not economics, so I'm not sure how the number was calculated, but there was they must have a math behind it. But then from the number of the websites, Web 1.0 is about 100,000 websites, and Web 2.0 is about 1 billion websites. And there was an estimation of the metaverse, there will be much more than that, much more than that. And it's no longer websites kind of thinking. Web 1.0 is, they said, it's read. You read about things, you got information from website. Web 2.0 is read and write, right? You use cell phone, you get information, you can change it. And Web 3.0 is not just a read or write, it's you experience it. You're part of the world, you go there, and that is how the life would be. So Metaverse is not a technology, it's not a one technology. And also Metaverse is not a game, right? So sometimes you will see some company will say this is a Metaverse is Roblox game or blah blah game. It's not. Actually, Metaverse is kind of you can think about it's a platform, or the reality we're going to live on. And there will be a lot of technologies will involved. A lot of you will contribute to those kind of technology involvement and that the commerce of that and innovation of that. So the question is, right, when we talk about Metaverse, we cannot avoid the question is real and virtual, right? What is considered to be real? What is considered to be virtual? And how do you define real, right? And so human, for human, if I'm an engineer, right? My background is electrical engineering. If you analogize human to a system, there's a couple ways you can acquire information from the outside, right? One is your eyes, that is visual. You have your ears, that is audio, right? That is hearing. And you have your nose, you smell. And you have your mouth, you taste. And you have your skins, that's kind of touch. That's a major way the 5 senses people acquire data from the out world. And then you use your brain to process that data. So your brain is like computer, CPU, GPU stuff. And then those things are like your sensors. That's how we do that. And we always say, show me, right? If you don't believe something, you will say, show me, right? Show me. 让我看. 我看, 眼见为实, right? That's Chinese way. If I see it, I believe it. That's how humans feel about the world. And Metaverse is of things when you really experience that in the virtual world. When you experience that, for example, if you are doing let's say hypothetically, you have a firefighting situation, and firefighter not necessarily need to go to the firefighter place. You can be in your office comfortably, but you will experience the real fire there, and then you can control the machines remotely to do those things. And is this real or is this virtual? That boundary could become more and more gray in the future. There's many technologies that will be part of the metaverse, or many existing technologies will evolve to be, support the metaverse and to become the metaverse. I just mentioned several of them. The first one is AR, VR, MR, or XR. Those things actually later on we will discuss. Those things are itself is also not have very hard boundary between those technologies either. And then AI is very, very important. Every aspect, almost every aspect of Metaverse needs AI, no matter including AR, VR, MR, those things. And I think that our first speaker talked about how important the AI, the memory issues, those things, give you some foundation about the importance of AI. And edge computing, cloud computing, that's very important, right? Our second speaker talked about that there's a lot of innovation in the semiconductor area to improve the performance, improve the efficiency of the chips, right? Those things enabled edge computing and cloud computing. And telecommunication, 5G, 6G. Now it's like a 5G, and in the future will be 6G, could be even 7G, and so on and so forth. And Internet of Things, because it's very important in the Metaverse, whatever you happen in the real world, in the virtual world, it will impact the real world. And then whatever you sense the things or get things from the real world will impact your virtual world. So IoT will be important. And the interface will dramatically change from traditional GUI, becomes a NUI, natural user experience. And then the cybersecurity and data privacy will be very, very important. So where are we now, right? There's a lot of hypes. Some people think that's 100 years from now. Some people think we're already there. So where are we now? Are we there yet? Let's see. This is I just use this graph from Unity. They said there's a different technologies, different aspects of the metaverse, and those companies are working on. So you can see a lot of companies have working on a lot part of the metaverse. So I would say we are in the early stage of metaverse. And the key part, the first part, to make the metaverse work, you need to be presence. You need to be virtual spaces. You need to have teleporting capability. You need to use NUI. The key technologies to support that would be, we call it VR, AR, holographic AR or XR, MR, those kind of things. Virtual reality, augmented reality, holographic augmented reality. MR is mixed reality. So here is a history of the, kind of like milestones of those AR, VR, XR, those things. Again, my background is not history. Actually, if you check my high school scores, my history does not do well. That's why I choose engineer, and I survive very well there. So this one can go back to early 19th centuries. They talk about how do you have two eyes to be able to see things. Those things are not the key, right? We're talking about engineer. This maps tells you, I think, one important thing is the speed of the technology development. If you look at the early stage, it takes, many years, decades to make a little bit development, little bit advancement in some part of the technology. But you look at the recent development, it's much faster, right? The first, when the VR goggle comes out, right? And then also Google comes up that paperboard VR and Oculus, right? That's kind of like an electronic higher-end version of the VR. And then if you look at the Google, the first AR glasses, that was several years ago. Now you look at the later on, you can see the involvement of the AR VR glasses, and the different technologies has dramatically developed. And nowadays the HoloLens has been used in the military, right? The U.S. military spent $20-some billion to purchase that. And then you go back to, in a history, that takes decades to make little. So the things will happen fast. So whatever you see now, don't discourage you. Don't be discouraged. It can happen very, very quick. That's the reason we study history, right? And here is the global extended reality. Extended reality kind of like it basically involves AR, VR, XR, whatever there are included, right? And it's developing, right? It's going. The data of past data is trustable. The data prediction for the future, you always need to have question that. Can be do better, can be worse. But this data provides you the information, right? It's going up. My background, AI and data analysis, right? So that's how, there's all the models are wrong, some are useful. But this one gives you a trend. The trend is something's going fast, going up. And here's some example of the things I think you probably have experienced, right? Pokemon Go, or you use this one to buy the furniture. I think Amazon has that capability. If you want to try furniture, use your cell phone. You can install an app, Amazon app, and then you try on your home. And you can see some of them use the car, use the AR capability to do that, and then you can use that to purchase stuff and to check. And then you can use the VR glasses with this the VR glass, and then they have some camera outside, can see and then change the view in your view, and then kind of like when you see around, they become automatic decoration for you. You can see house, see home, see those things. That's also is already used, right? So that's a lot of things I mentioned. VR, AR, sometimes the boundary is blurry. So you put a camera there, you can see the real world and feed those real world information into your VR world. Is that just a VR, or is that just an AR? It's between, right? It's between. So. Sorry. And this is a development in terms of the computation devices, right? In 1970s, right, we kind of like personal computers are still very precious. Probably only big companies, corporations can afford. And it's about, you used to work. And then later on in 1980s, right, we could become a more and more personal computer, and you use that computer to do professional work. And then later on in 2000s, right, smartphone become popular. A lot of people actually just work by using smartphones and become, smaller and smaller. And then now in the 2010s, became to have a digital reality, right? Now it's 2022, right? You still see some of those things are still developing. Digital reality is including AR, VR. It's not only just for you to communicate, for you to work, and for you to entertain. And so this is kind of like a definition of different VR, AR, MR. So strictly definition is VR is basically you only see the virtual world. You wear those goggles and block your view of the real world. And the prediction of the VR technology is to replace like movies, possibly replace some of your personal computers, because that's definitely give you 100% privacy. You don't need to worry people to take a look at what you're doing in your computer. And AR is basically there's a overlay of the virtual things into your reality. And definition of MR is basically you may change some part of the reality, and plus you overlay some of the virtual things into reality. So that's kind of a definition. But again, with the technology, those boundaries are become more and more blurry. So this is an example of the US VR AR in healthcare, and a lot of healthcare is now, I would say, applications still very rudimental, and a lot of those applications are actually in the therapy area. Digital health therapy popular used for the AR VR applications, and actually some medical schools are using HoloLens to help medical students to learn surgery, because those dead bodies are actually very, very expensive, and you can only keep short time. Again, I'm not in the medical area, so what I said about those things may not be very professional. But if you use a HoloLens, you don't no longer need to deal with real bodies. You can have a simulated body and to do those simulated surgery and then study. And that's dramatically reduced the cost. Each HoloLens is about $2,000 to $3,000, right? And each dead body is about $3,000, and that body can only stay for so long, and then so many people can, manipulate with that. But with the HoloLens device, everybody can use it and can use it for a long time. So that's the technology making things much more convenient and cheaper. This is an example. And for the VR, you see a different kind of a level of goggles, and as cheap as in the motorized side, right? Those the Google engineer put a cardboard version, maybe $1 or $2. You can make it yourself, and then from the left side, those things are more professional made from different companies like Meta, like some other companies. They are making that. And there's a virtual reality applications, right? Netflix has VR movies, and also if you go to YouTube, you can some movies they actually, or some videos they set up to be able to view in the VR. So you can just click that button and you can use your VR goggle to see it, and you can play games. There's some of those VR games, not many. Some of those VR games. And then you can do fitness. Recently, I think last year, Meta purchased a VR fitness company, Supernatural. That is, and then now in the Oculus, actually, you can use that. It's a fun fitness experience. If you have not tried, I would strongly recommend that. And then VR therapy, like for PTSD, and also for some of those behavior issues, they have that therapy. And actually in Stanford Children's Hospital, they began to use VR for kids when they need to do surgery or they need to do some long process, then to wear this VR glasses, so distract them. Then, the doctor can do some things. Yeah, so the VR is also used there. And VR has been used for, some company has developed, use VR-based data analytics. So you can really see the data in the 3D dimensions and manipulate with that. It's much more visual, and you can see a lot more data easily than your dashboard screen. And obviously, you can see a lot of ones, VR social, Facebook, or Meta has been trying to push the VR social app, right? That one is still very rudimental, it's still not there. And their advertisement is much more impressive than the actual product. But I believe that if that product can make it to be really what it did, and it will be very attractive and very fun things to play. And mobile AR, right? You use your phone to do the augmented reality. And the first and the foremost one is Pokemon, the Pokemon Go, that game. And that game made billions of dollars. That's amazing. And they just have little monsters into your mobile phone when you play it. It's internationally phenomenal when the Pokemon Go came out. And obviously, there's a lot of different applications, like they use to buy furniture, or they use to play some games, or do the digital books. Those things are mobile AR. And the mobile AR are actually powered by two companies. One is Google, mostly. One is Google, one is Apple. They have a mobile AR core. One is the AR Kit, and one is AR core. This one, again, I used from internet, so those comparisons, this one I would say make AR, the Apple's much better than the Google, but there's something can be debating about, tracking, about the sensory response, about, object recognition, or those kind of capabilities. One thing is the last week, Google just announced that they have the 3D map. It's not directly connected with AR or VR yet, but that one's definitely in the track to provide to more powerful experience for people. Not just to use a screen to show. Imagine like those 3D maps, you can make the AR, VR games, applications much more fun. So that's why I want to mention that. It's amazing. So, and for the AR glasses, It's also from cheap ones, couple $100 to couple $1,000 ones. The top right corner, that one, it's more like a fashion. It's for you. That one is from Meta. It's the Meta work with fashion glass company, Ryan, and make that one. So it's basically mostly for taking pictures. You can use that. There is a camera there, and you can take pictures and then to save them. And then they top the second one in your right, actually, the top left, in your top right. That one is more like somewhat like a Google Glass, and you have that little display just hanging there to provide you some digital indications. And the bottom left of your hand, that Google Glass may look like that, but I don't know, right? So I don't know. So rumors said that there could be like that. So it's they compare to the top glass. This one has bigger view, display areas, and then something like that. And then the one actually in the bottom left, your side, that one is more like the one we showed in the free guide, right? You have very light glass, has all those powerful things to be able to show. And in the bottom, your right side, that one is HoloLens-like, right? Those heavy gigs, very heavy, but it's standalone. So that one is a standalone. You don't need to use computers. You can wear it. It's become lighter, but it's still very, very heavy, and it's use a lot of power, but it's more capable to calculate. And then the left side, in your right side, that one, the glass looks very light, but then they need to couple with your phone, your smartphone. So the computational power should be from your smartphone, not from the glass. Obviously, they will need those semiconductor experts to make things smaller, lighter, so we can have a better glass experience, right? So holographic AR, so basically you can have, you don't need to wear anything. You just use a display and use a camera, and you will see yourself into this mixed reality or holographic AR world. And then the left one is what our company is doing. We do holographic AR platform, and we also have holographic AR education program for K-12 students for them to create Metaverse and experience that. And then the right side is an example. I just use the Olympics, the Winter Olympics. It's a little bit of AR, not very, big. So when people are running around, and then they have those things project on the ground, follow the dancer to show different those little effects, beautiful effects. Again, I'm an engineer, not artist. I think it's beautiful. And that is kind of like an AR world. It's interactive, and it's dynamic, and showing you the world. So this is like you don't need to have glass goggles. And that is also an important direction in the future. People don't need to use something. So there's a lot of the question is, we don't see everybody wear AR, VR things, right? We don't see everything become the displays and then to show. Then obviously there's a gap, right? Whenever there's a gap, then there's opportunity. So there's a lot of opportunity in this area from hardware and software and then platform ecosystem. Again, this is just a portion of it, not the exhaustive list. From hardware, for example, if you look at the glasses, those things definitely need to be lighter in weight and more comfortable. Again, lighter in weight, and then plus, they need to be larger view angles. No matter VR, AR, especially for the AR glasses, the view angles is very limited. If you look at the HoloLens, the commercials, it looks like you have those glass, you will see fantastic whole view of the world. But when you really have a HoloLens on your put on, you only see very narrow view. It's bigger. The version 2 is better than the version 1, but it's still a lot of room. This angle to improve a little bit, it's actually a lot of engineering innovation behind, right? And then for the display technology is not only for, like if you have a whole wall or a whole, floor kind of those kind of AR display, but also for the glasses, AR glasses, VR glass or goggles, those display technology need to dramatic improvement. And also another possibility is the 3D holographic AR display itself. So really display things in the 3D. There are existing, but it's very, very expensive currently, and plus they don't show color. It's just to show those, lights. They one colored lights. It need to be greenish, those kind of light. But I think that's also in the future will be the display direction. And sensors and controls are still not very accurate. It's much more accurate than every year, but it's still not that accurate. That's why sometimes people will complain that when you wear the VR glasses, you may get dazzling, or AR glass, you don't feel those things, because your brain are very sensitive. And then when you see this virtual things is rendering digitally, and then sensor, you need to follow the sensor. If the sensor is a little bit delayed, and then the rendering is a little bit delayed, and then you will sense it. So, and the accuracy of the sensor also is important, because your brain constructs those information to you, and then the brain sees something is not correct. Then your brain will correct those information for you, and that make people feel dizzy. Another thing is I think behind the sensory and the control, this dizziness issue people complain about VR or sometimes about the AR is actually because this 3D. There's the 3D technology basically because your left eye and the right eye, you need to see things differently. And then, so there's two different images into your eye, and then your brain constructed those 3D images to you. And so that's why if you go to watch the 3D movies, and if there's a minor rendering or technology difference you feel non-realistic, your brain actually try to construct it and then try to make it to make sense out of it. Then that's why your brain is very tired. If you go to watch a 3D movie, you often feel much more tired than watch a 2D movie, because your brain constantly constructed the 3D things for you. Yeah. And then computational performance. It's obviously it's always right. So that's why we talk about Moore's law. We talk about how we need the experts in the semiconductor field to make it to be much smaller, much more capable. Those things, the computational performance is always needed. And also wireless communication, right? So when you wear those goggles, you want it to be transfer, your phone. You don't want to have a phone has a long line to connect it to anything, right? The same thing to the goggles, to the glasses, or even if you want to have those displays, and how do you want to transfer that digitally from one location to another? Wireless communication will be important. And then IoT functions, right? The IoT function capability, again, in the Metaverse, you wanted to have virtual things impact the real world, and real world things impact the virtual world. So those things will be very important. Another thing is for the hardware part is actually variable. Variable things is actually will be more and more important in the Metaverse. If you watch like a Real Player 1, you will see when the player experience those virtual world, how do you want to feel it's realistic? Is those feedback, those vibration or whatever, those feedback from your wearable gives to you the feeling of the realistic. And those things are still a lot of a blank, I would say, in the field about those wearables. And to make you feel, not only just to see, but also feel about realistic things in the virtual world. And then in the app and the software, there's a lack of contents. Definitely. If you buy an Oculus, you will see there's only a handful of apps, and most of them charge you heavy money. So not like you open your phone, there's thousands, millions of the apps you can find. And the lack of the social elements, right? So you want to, when you use your AR, VR, you hope to be able to use it in a way with your friends to enjoy it. And then a lot of the social applications in that side is still developing, not as cool as what we hope to see in those commercials or in those sci-fi movies. But we're getting there. right? And then it takes a long time to create the application, no matter AR or VR application, because again, the content creation is difficult. You need to have a lot of artists and also programmer involved. That's a challenge. And then many applications are still in the early stage. That's again because not many users, so not many possibilities there, and then that's discourage the developers in the field. And then that's kind of like the situation is there. And also entirely the platform and ecosystem are still very early stage and still not there yet. Then it depends on who you are, right? If you are developing this field, great, this is an opportunity for you. This is a problem, this is an opportunity. If you just want to become a consumer, then you probably need to wait a little bit, right? So AI is, so how about AI applications? AI applications actually is in almost every aspect of Metaverse. No matter you think about you're doing the VR, AR, a lot of things behind the AR, VR to calculate your data, to present the virtual information, to enable the interaction, to do the natural user interface. All those things actually behind it there are a bunch of AI engineers are working on that. So there's the AI algorithms. So AI is everywhere in the Metaverse. For example, for the presence and the virtual world, right? How do you construct the virtual world, which will make this person feel comfortable inside? When you move a little bit, how do you decide I moved in this angle and then I should coordinate with the human feeling of the movement of this view? And how do you detect my movement? And those things are all behind as AI. And how do you do the digital human, right? In the virtual presence, you need to have a digital human, not only just a digital world, the digital human, and there's a 3D model. You need to make that a 3D digital human. We don't use 3D model, we use digital humans because they need to have a human-like characteristics, be able to talk to you, be able to interact with you, be able to social with you. And then you make a computer to be able to talk as a people. That's behind it. It's AI, right? You have a speech language, natural language processing. You need to have the speech recognition. You need to have this chat capability. All those things behind that is AI. And then, how do you, a lot of those things you probably want to change based on humans' feeling. How do you detect that? Those things are all behind that AI. And again, natural interface, right? So you don't no longer in this, you want to use a keyboard or mouse. You want to use your hand gesture, you use your voice, use the expression, use your behavior to control the things there, right? I just do this one. What do I mean here when this virtual world is presented? When that virtual world, I may do the same action, but mean different things, right? Then there's a lot of things behind. It's actually powered. It can only be powered by AI. It's recognition, and then data analysis and interpolation and presentation. I need to present this data based on the user behavior, based on who you are. Maybe if this is a girl, maybe I will show more pink world. If this is a guy, I may show more blue world. But obviously, I sterilize, man and woman's difference. But this is how if it's you comes in, this maybe the virtual world will decorate it like that way. And then if you are good mood, maybe this way. You are not good mood is that way. So there's a lot of AI actually behind it's mostly by AI, I would say. And the privacy and the safety, right? Again, in the Metaverse, the privacy and safety is a big issue, right? How do you recognize this is this person? Then you can present this data to that person, right? You need to do biometrics, human identification, and then you need to do privacy, the data analysis, and to see which kind of data can be extracted, which kind of data is not extractable, and which data actually in the future can be stored, which data cannot be stored. There's a lot of those things actually behind that. And then how do you detect
malicious attacks. And also because of this, virtual world, so deepfake is a big issue. So it's basically there's a lot of things can maybe presented to be like you, but actually it's not you. Right? Here's an example. Can you kindly click the video in the middle? Thank you. So this is a kind of like a Queen's address. Is there sound or? No sound, okay. Anyway, this sound will be very similar to the Queen, right? So this is a kind of like every year, the Queen will address her nation. And then this is what a clip about that. But this one is a whole thing is faked. It's not real. It's not like you have some actress to shoot in the green screen and do it. It's the whole thing is digitally generated. And then including sound, everything looks very, very close to Queen. So deepfake will become a much bigger problem in the metaverse because you are represented somewhat digitally in the metaverse, and then is this real, truly you said or not you said, right? And then how do we say this is real and this is fake, right? And that's kind of things will become much more challenging. And then the AI behind it. Again, deepfake need to use AI to make it happen, and then to detect the deepfake, need another group of AI engineer to find what is not. So, again, if you learn AI, there's a infinity of opportunities for you, just doing this fake, non-fake stuff. Okay, let's move to. So there's AI challenges and opportunities, not perfect, right? That's why we always has jobs, right? We always need to learn. That's job security things, right? So then AI, again, in the hardware, right? Even if you don't really do the AI algorithm side, but if you do semiconductor engineering things, you have a lot of job you need to do, right? AI, edge computing, again, edge computing really, I like this edge things. It's basically just a kind of personal computer, right? But then in the metaverse, you want to be wearable, you want to be in your glasses, you want to be mobile, so you want to be much smaller, right? And then how to make it smaller, and then you want to be more powerful. So and then you want to have more data processing capability, more memory and more memory processing. All those things involves again innovation in the semiconductor engineering field. And also more, application software, right? You need to be more user adoption, acceptance, and user-friendly, and you need to be more accurate. When you do any algorithm design, you will heard, again, all the models are wrong, some are useful. That's also applied to the AI models. It's impossible to be always 100%, right? So there could be something wrong, and then you always need to improve. And then you need to be more intelligent, more and more like in the future, could be the robots will be more intelligent than humans, right? And then you need to be more integrated applications, not just one thing, but just a whole thing applied to solve a problem, right? And then more cross-platform, AR, VR, and PC, mobile phone, and all those things the data can be used, can be incorporated. And then, how to accurately articulate. A lot of things in the AI world is you need to articulate how this AI algorithm works. And that's actually is a new issue because this involves law and fairness for the society. So when they use that, right, you don't want to say because I use a bunch of this data and then I get this result. That's how the AI algorithm actually works. But then when you use this training data, you may unintentionally biased towards a particular population, or your algorithm is not explainable in such a way, today may work like this, tomorrow may work like that. Then that will make it difficult to use AI as an algorithm to be used in government applications or public applications. So actually in Europe, there was a law in the European Union. If you use AI to do something, you need to explain how your AI algorithms works in the human understandable criteria. So for example, the criteria will be if you need to be able to drive your car, right, your eyesight need to be certain level, then that is a human understandable criteria. But the AI may not be that easy to explain that, right? So that's also another challenge in the applications. And then, so where are we going to be, when will we really have a metaverse, just like now we have this Web 2.0 everywhere, right? I really don't know, but you look at history, right? Everything happens, this journey is not linear, right? Everything happens much faster when in a later stage. If we use the mobile phone as the example, right? Mobile phone, the iPhone is actually as the status of the Web 2.0. When it just came out, it was, at the beginning, right? It's very low, and then you can see it's more like exponentially increased until saturated among the population. I would say same thing will happen to the metaverse until, at the beginning will be very low, you don't see much change, but the sudden was exponential change with that. So I hope to be able to discuss, we can have a discussion about, right, what are the innovation opportunities for you, right? This is why metaverse is not just for people who do AR, VR, or AI. It's actually for everybody. If you are, if you're an engineer doing semiconductor, if you're an engineer doing simulation, if you are a marketing person, or if you're educators, there's a lot of, or if you're a medical professional, there's a lot of possibilities, right? What can happen? I'll be happy to discuss with you.
Thank you so much. Before we take questions, we would like Dr. William Kao to present a recognition plaque to you. Now let's have a Q&A.
Any questions?
Well, first, a very serious question. Are you, Dr. Du, are you really here, or are you sent through the metaverse?
Well, I'm here. But next time, maybe I should send myself here.
That will be a wonderful application. So that really is a kind of my question. A few years ago, we all saw like the 3D television was all the rage, and everyone come out, and then kind of fizzle. Mm-hmm. Are we also worried about the metaverse is a solution looking for a problem? Mm-hmm. Kind of continue with that question is that, do you see a consumer level application that we will say, wow, mm-hmm. we really have to have that metaverse mm-hmm. in order to really enjoy it?
Oh, yeah. This is a very good question, right? So that's why people will have, actually there is a lot of suspicion about metaverse possibility and think there's a hype, right? And then because historically, there are technology up and there's a technology down, right? And let me give you a couple examples, then you can tell me from there, you can think, is this something useful? Will that come in the real world? So NASA, they built this moon equipment, right, goes to the moon. And traditionally, it would take 5 to 6 years. They subcontracted out to Lockheed Martin. Takes billions of dollars, a lot of our taxpayers' money. And then now they use the holographic AR capability. So they build things digitally. They first build a 3D model digitally, and then they use HoloLens, they use holographic AR to test it digitally with different level of engineers, simulations, and also scientists, astronauts to test it digitally. And then after they solved every aspect to make sure every aspect is good, then they build the real thing. And after they build it, in the past, even in that level, after you build the 3D real stuff, right, it takes an experienced high-end technician to take a long time to do it. They often make mistakes because every part, how to put it is very unique. And then, there's a lot of science behind it and why they build this way. With the use of holographic AR technology, then when the technician to install those kind of equipment, they can digitally automatically give this technician, yes or no. You make a mistake, and then also instruct the technician how to do it. And then with that, there's a dramatic reduction of the mistake. And then the whole thing, actually, they finished half year. So before 5 to 6 years, now half year. Before, you need to build many different models and try out and do it again and again and make mistakes. And then still, there's a possibility they may crash on the sky. Now, you do thoroughly all aspects of the things to test, and then there's no mistakes, and then the installation becomes very smooth. And the cost is less than 10% of the original cost. The time has changed from 5 to 6 years to half year. And in the future, could be even faster. So this is an example of in the high-end aerospace, right? So let's give you some other examples how this will impact, our life, right? So, for example, for education, right? Just use education as a way. When now you look at the way we learn, right? PPT, or use paper or use something, right? But in the Metaverse world, you can really get into that. You can, if we want to study Mars, you can go to Mars to study, and nothing will become abstract, become very vivid. They can learn things much faster. So for example, we do that for students. We have some autism children. They had difficulty to understand some concepts or empathy or social. When they use holographic AR, they can quickly understand it, and they can improve a lot of things dramatically. So this again is just some samples, right? Some other samples is like, again, some part is not Metaverse yet, but it's going to be. Let's use a war example. It's very cruel, right? Russian and the Ukraine war. We don't want to say which one is good, which one is bad, whatever. But we just from technology point of view, understanding, right? So there's a lot of pilots. They call the pilots. They no longer really need to do it and go to the field to drive a suicide airplane to kill the enemies. What they do is they can use remote control and to really kind of like in the world to see it and to remote control things and to do it, right? It's kind of like a semi-virtual metaverse, but not really there yet. But that one has dramatically improved the efficiency, reduced the cost or the deaths of the people who use this technology. From technology point of view, I don't want talk about something else, but this is basically is give an example of how Metaverse can used in the future. Is you can be a very safe location, humans, if you want to explore the dangerous location, no matter if there's a disaster or if there's some place people cannot really get into. You can use Metaverse. You can get into that world, and you can do it in your very comfortable on your office, with air conditioning around your home, and to do things. So those things is the technology is solve these problems, real problems, as our speaker said, right? You really need to have a problem, and to really solve this problem, improve efficiency, reduce the cost, make things move faster, right? So the benefits are there, right? So that's why the technology will, it's not just a technology, it's a kind of platform, right? It's a whole thing, right? It's coming. It's just a when. It's not if, it's when. When it's coming, when this technology infrastructure will be available to make it happen. And let's use the pandemic as an example, right? During pandemic, most of us probably work from home, right? And we use Zoom to conduct Zoom or some other, a web communication method to do that, right? It's not a perfect Metaverse situation yet, but in some sense, it's half Metaverse, right? You are virtually into the conference with other your colleagues virtually there and to conduct meetings, things, but that's reduced the cost, improved the efficiency, and also make things happen even in the pandemic, right? So So yeah, thank you.
Would tourism be one of the early applications of this, where you can visit virtually some place that you want to go without actually going there?
Yeah, so the question is a very good question, right? Is a tourism could be an early application, one of the early application? I would say sure. That's like, for example, make it easier, right? Google just launched the 3D Google Map. Actually, one of the applications is that if you want to go to London, let's just directly, you can use Google 3D Map. You can go to London to see those things and then have weather. But obviously, that is, I would say Google's position is more enabler, right? They provide this API, they provide the enabler, and then there'll be some other app makers can make it to be next level of a tourism, this AR, VR experience. And it's realistically, you really feel you are now in this moment in the London, you experience the rain, experience the sunshine, or experience something, yeah.
We have time for one last question because we will invite all speakers back on stage to take a group photo with us, okay?
Thank you. So could you introduce more specifically about your products and technology at Integem? Do I pronounce it right?
Oh, yeah, sure.
So in terms of differentiators of your technology versus those big tech corps have been doing, also potential cooperation and synergy with them, I see you have a summer camp at Integem. So I assume your ambition lies more on the, or strategy lies more on the biosystem level, like a specialization in technology, educational technology. So maybe more introduction of your strategies too.
Okay, sure. Thank you very much. First, I did not pay her to ask this question, right? I do appreciate that. So give me a free marketing case for my company, right? So what we do is we build holographic AR technology, and we are a technology company. Our first product is into education, into K-12 for elementary school to high school education. There's partially because of my background, also I was in the teaching education, so I feel in the K-12 education is way behind, the curriculum is way behind. If you look at the curriculum they have now versus when we were little, it's no much difference. And then the technology has been changed dramatically, and unfortunately it did not change how they learn things. So that's one reason we want to use this one to help students to learn. In terms of the differentiation, is one thing is I believe actually the Metaverse make it to be comfortable. Obviously there's different applications. You may need to use VR, you may need to use AR glasses. But if we want it to be general public to use, eventually you need to have things don't need to use glasses, because that is a convenience. You don't need to wear anything. You just go anywhere, those things will be presented to you. That's my vision of the Metaverse world would be. You don't need to wear glass, you don't need to wear anything. That's towards our development of our holography. You just use a camera, you just use a regular display, you will see yourself into your own creative metaverse and interact with anybody in the world. And we build the education technology into they help the students to learn how to create the coding, they create the metaverse content, because one thing is in the metaverse content creation is a problem. So we make the content creation to be simple, and we even enable young students to do that. We also make them to the students who want to learn art, animation, fashion. They can use that to design their own art, animation, and fashion. So they can interact with the things they created, and they can learn, a lot of hard, high-level things like they can learn 3D when they were 8-year-old. They can learn AI when they are just a 10-year-old and create the AI holographic AR applications. So we want to enable those young, energetic, creative minds, and then they can create much more things. And when I get old, I can enjoy their my better life because they are doing better. I'm just kidding. And then actually, we also find this technology in general has a lot of impact to help people who has difficult to understand things to be able to learn things easily. So for example, people who has autism, who has difficult to learn empathy, know programming language or know something, right? This one can help them efficiently to learn. For example, we had a 12-year-old low functional autism child who can at most speak 3 words. And then with a couple weeks, just every week, one time, this kind of use holographic AR to do speech therapy session, and he can read English, he can read those things, and can speak, and he can understand a lot of things, and he feel very enjoyed, and a dramatic improvement in terms of his condition, a lot of conditions. So there's a lot of possibilities there, and then I would say this will need a lot of people's work, not just us, not just Integem, but it's also, we hope there's better chips. and then also, we hope to have better AI, this, memory solving problems, solve a lot of those hardware issues and things to make things work, yeah. So I hope you answer your question, but I can talk a whole hour about how great our product is, but yeah.
Okay. Our speakers will stay for a while. If you have more questions, more things to discuss, I'm sure our speaker will be happy to take some questions. Now, please, all speakers and officers, please come back to the stage. We'll take a group photo. Let's thank our speakers again. Thank you, everyone, for attending the afternoon session. Thank you so much. This will conclude our afternoon session, and in about 6 p.m., we will begin our banquet session.